I feel it blessed. Rose for Christ, you gotta come. Remember in class, we don't chew gum. Get off your phone and pay attention. Not to mention, you're your detention.
Hey stats lovers, let's go over 16.5, chapter 4, probability test version B. Carl wants some ice cream. The probability that the following flavors, these are the following flavors: chocolate chip, caramel critters, and blueberry cheesecake. It tells me the probability. I do notice that they're in different forms: decimals, percentages, and fractions. And so it might be easiest just put them in decimals. So that's already a decimal. If you take this one, and this will be 0.55, that's its equivalent. And then 1/5 you can multiply by 20 over 20, so I got 20 over 100, which would give me 0.20. And then here, I need to put them in a particular order from most to least. So the most would be 0.55, that would be caramel critters. That should be blue. And then chocolate chip at 0.25. So chocolate chips. And then our red, because 0.25 is greater than 0.20. This is my blueberry cheesecake. Okay, and so that would be the order I would write them in. Question number 2. From a pack of cards, standard deck of cards, there are 13 per each suit, and there are 4 suits. The suits are hearts, clubs, diamonds, and spades is like an upside down heart. And the 13 cards are 2 to 10, Jack, Queen, and King. Those are the face cards. Determine the probability of each event mentioned in the first column. So the first column here, this is the event here in yellow. Yellow. And write its corresponding probability. So probability would be over here. Round your answers to the nearest hundredth. The nearest hundredth is 2 decimal places, but you would have to look at the third one, but the hundredths is here. Okay, so a club, there are 1 of 4 suits. So you could have done 13 of 52, which reduces to 1/4, which would give you 0.25 as your answer. A black card, well, black is the spade, try to color that in, and the club. So that's half the cards. That would be 26 over 52, which will give you 1/2, which would give 0.50, 50%. And then let's pick a different color. A 7. There are 4 sevens, 1 heart, 1 spade, 1 diamond, 1 club, and this would be 1 out of 13. So if I put in 1 divided by 13 in my calculator, I get 0.0. I'll just show you what I have. And so I'm looking at this number, it's 5 or higher, so this number is going to round up, so 0.08 is my answer. Number 3, given there are 3 purples, 2 blues, and 5 orange marbles. 3 purples, 2 blues, 5 oranges. So that's a total of 10 marbles. You select a marble without looking and putting it back, and if you do this, I told you guys in class, 10 times. What is the best prediction possible for the number of times you will pick a marble that is not blue? So if you think about it, it's probability of not blue, which is the probability of purple, I'm writing in purple, or the probability of orange. So probability of purple plus the probability of orange. And so if I do this, Now, when it says 10 times, I'll come back to that, but the probability of purple is 3 over 10 plus orange, which is 5 over 10, is going to give me 8 over 10. So if I do this 10 times, that's the 10 times, I expect to get it to be 0.80 is my answer. 80% of the time I predict, of the 10 times, I predict 8 times. So if you told me the probability of not blue is 0.80, the number of times, you can say 8 times. So either of those, I'll give you full credit. Number 4, using the following figure, in order to pick a card, there are 3 cards here, and a number. So a number of marbles, 1, 2, 3, 4. That's a 3. Determine the number of possible outcomes. So I pick 1 card and 1 marble, and then 3 times 4 gives me 12 is my answer, so that would be C. True or false, the event 4/5, so I'm going to make this out of 100, because that is a common denominator of the other one. It's basically put in as a fraction too, not 120. So I get 80 over 100. And over here is more likely to happen than 3/4. So I'm going to multiply by 25, because that would give me 75 over 100. Is 80 bigger or more likely than 75 out of 100? That is true. A is your answer.
All right, which describes independent events, right? You know, I talked to a lot of teenagers, high schoolers, and what do you guys want? You guys want to be independent from your parents, right? Whatever your parents do doesn't affect what you do. Now, it's telling you disjoint events, which basically means another way for saying mutually exclusive. They're not related. And then it says select all that apply. The bag contains red, green, and blue marbles. You randomly draw 2 marbles at the same time and want to know the probability that either is red. So if I pick whatever it says, you know, if I pick the first one, you know, let's just say there's 10 marbles and then 5 are reds, that'll be 5 out of 10. But if I'm picking 2, that means the next time, let's just say the first one was a red, that means I have a smaller chance because, or the probability is affected because there's 1 less marble in there. So this one isn't dependent, right? It's dependent on the first pick and affects the second one. B, you roll a number cube and spin a spinner. You want to know the probability of rolling a 4 and spinning a 7. Well, the cube and the spinner are not attached. So these are independent events. So this is one of them. C, lunch includes your choice of a salad and your choice of vegetables. You want to know the probability of choosing a house salad and a broccoli as your vegetable. So think of it as like 2 separate dishes. You have all the salads. You randomly pick one out of your fridge, and you randomly pick a vegetable that's not a salad. Okay, that's the hard part. I'll just make sure that's clear. But they're independent. Kind of think of it as, I don't know, sometimes there's glue on things. So can imagine the vegetable is glued to the salad container. That's how it's affected. But these are not. They're independent. Okay, and D, a math class has 25 students. The teacher randomly chooses 2 students. You want to know the probability that one of the 2 students will be a female. Well, if you choose one, and let's just say there are 12 females in the class, the first probability is 12 out of 25, but once you pick that person, you can't pick the same person. So you'll notice that my numbers here are not the same. So it can't be D. Your answers are B and C. All right, for mutually exclusive events, A and B, this means kind of like in the Venn diagram world, the circles don't overlap. So the probability A is 5/10, 5 over 10, and probability B is 1 over 10. What's the probability that either event A or B occurs? So they want the probability of A plus the probability of B. So all I have to do is substitute them in there. They have no overlap. No overlap. So that means you're not subtracting. No subtraction. You're not subtracting a double count. Does that make sense?
What is the probability that a random selected person is left-handed? Probability that it's left-handed, given, that's what that symbol is, given that they are male. So basically, I need to figure out the probability that they are male, and then within that they are male, the probability that they're left-handed. So males, there are, if you add those together, you will get 100. So there are 100 males. And then given that they are male, how many are left-handed? So that would be 13 out of 100. And that would be choice B.
Spinner here. Jerry spins the spinner once. What is the probability that it is a 3? So the probability that it's a 3. Or, which means we're adding, and then probability of an odd. Okay, so let's look at all the odd numbers. 3 and 5 are odd numbers. So probability of 3 plus the probability it's a 3 or a 5. Okay, so you'll notice probability of 3 is 1 out of 4. And probability of 3 out of 5 is, there's 2 numbers. Okay, but you'll notice that we did what? We're counting the number 3 twice. You guys see that? So we actually have to subtract the double counting. In that case, that would be the probability of 3 because it's counted twice, so that's 1/4. So fractions, 1 plus 2 is 3, minus 1 gives me 2, 2/4, and 2/4 reduced is just 1/2. 1/2 is our answer.
All right, let's go over this last question. The Venn diagram shows the distribution of students who take Spanish and or French. Represent the data in the Venn diagram as a two-way frequency table by dragging the correct values into the table or writing the values. Okay, let's do French. French is going to be this circle. So French is 4 plus 2. That would be 6. And then I will do blue. Spanish is 2 plus 9. That would be 11. And those who are not taking anything, this would be 5. So that would be no French, no Spanish. Okay. Another one that we need is the 2 is that they are both taking yes to French, yes to Spanish. So that would be a 2. Okay, so now you can just go in and fill in everything that we're missing. 2 plus 9 is going to equal 11. Going this way, 2 plus 4 would give me 6. Taking the people not taking French, 9 plus 5 would be 14. People who are not taking Spanish, total is 9. 11 plus 9 is 20 is our total. Hopefully that was helpful. See ya.
Mathematics includes the study of quantity, structure, space, and change. Math can be so complex it could be considered strange. So strange equations could be rearranged. Don't even get me started on fractions. To multiply them it's going to take a lot of action. But math can be simple. All it takes is practice. Your brain is like a muscle. Make sure it's active.